In this video, you will learn about the normal distribution and its application and how we use the normal distribution in different fields. So basically, a normal distribution is a bell-shaped curve like this. You can say many real-life variables like height, weight, IQ test, and weight of children in family, intelligence, all these are distributed normally. And if we say mathematical equation mimic, which represents 1 over sigma under root 2 pi e to power minus x minus mu over sigma whole square. This equation is known as normal equation, and this bell-shaped is the normal distribution. And we say the normal distribution is a parent distribution uh, because at any stage, most of the distributions becomes the normal distribution. So in this video, you will learn the situations where we can apply the normal distributions and how practically we use this distribution in different fields. So this is the most important continuous probability distribution and used in statistics and known as normal distribution, and we use it in many real life variables like height, weight, age, marks of the individual score. So all these are the examples of normal curve. So if we say a continuous random variable x having a bell-shaped distribution, then it is known as normal random variable. And in mathematical equation, it depends upon the two parameter. One is the mean and other is the variance, standard deviation. So normal distribution have these two parameters, mu and sigma. These two parameters tells us about the spread and variation in the curve. Like if our curve of the data falls like this, so we can say this is a bell-shaped symmetrical curve, and most of the data is in middle, and with mean median mode lies at the same point. They are identical, so this curve is the best fit of the normal curve. So if we distribute this curve with different standard deviation or with different sigma limits, we can see the 1% sigma covers 68.26% cases. Like this is 1 sigma and this is +1 sigma. Between this yellow portion, the 68.26% area covers. And when we talk about the minus plus 2 sigma limits, it means that this blue to blue covers 95.44% of the cases. Means in this 2 sigma limits, we cover the normal curve almost covers 95.4% cases. Whereas for 3 sigma, plus minus 3 sigma, this curve covers 99.72% of the cases, and remaining leftover was this minor portion, which contains plus minus 4 sigma. And so we can say, so we can say the percent of values greater than one standard deviation is 0.16, means 16% area is only greater than +1 sigma, and greater than -2 sigma, there are 98% area. This curve, this shaded region, you can say cover the 98% area. And similarly, percent of values greater than +2 standard deviation covers 2%. And we can see the mean plus minus sigma covers 68% of the score of the curve, and 2 sigma covers 95% of the curve, and 3 sigma covers 99% of the curve, whereas remaining covered in 4 sigmas and so on. So normal curve, if we conclude this curve, we can see this is a symmetrical, bell-shaped, unimodal, and identical curve. How, if you can see this curve, this is symmetrical, identical, unimodal curve as it has only one peak. So this is the property of normal curve. It has only one mode. You can see this is a unimodal curve, and bell-shaped due to its equal distribution of area towards left and right. Identical as it has mean median mode at the same point. Symmetrical, it have 50% area to left and 50% area to right. So this is one more beautiful characteristic of normal curve that when we use it, it explored the standard scores. By the standard score, we mean that we express the standard deviation units, making it much easier to compare variables as measured on different scales. And there are many kind of standard scores. The most common standard score we use in the normal distribution is the z-score. Basically, this z-score helps us to find the area, to find the probability in area tables. We can directly calculate this probability, or we can directly compare this z-score with the area tables instead of integrations. So score states the number of standard deviations by which the original score lies above or below the mean of a normal curve. And this is not a single curve. Normal curve basically is the family of curves. Like if we have the different mean and different standard deviations, we get the different curves. So we have the variety of normal curves in normal distributions. And this is the z statistic or the z score, which is known as standard normal, by which we can calculate the value of normal z. So this standard score z, x minus mean over standard deviation, gives us a score which we use to compare or to conclude our study. So the standard normal curve is the distribution of normally distributed standard score with mean equal to 0 and standard deviation 1. So standard normal score, which is z, have the beautiful characteristic in which the mean is 0 and variance is unit. So z-score is nothing more than a figure, mean square, which represents how many standard deviation away from the mean. We can calculate how much our variation exists in the series, in the data, or how much variation deviate from the central value or the middle value. So for score above the mean, we get the positive sign, and for the score below the mean, we get the negative sign. And calculate the z-score for blood pressure, like if we have 140, the sample mean is 110 and the standard deviation is 10, then z becomes plus 3. As you can see, the 140 blood pressure score lies onward the mean or above the mean. So this gives us the positive value or the positive sign of the z-score. So this is the way how we can calculate the standard normal score, z-score. After calculating this, we have different, we have area table, one for the positive values and negative values, and we can calculate or compare the probabilities from that table. So comparing scores from different distributions, this is also the beautiful property of normal curve. By using this, we can compare the different distribution score here. For example, assume that an individual took 2 tests in reading and mathematics. The reading score was 32 and mathematics was 48. Here, on the basis of this score, one can conclude that the student is better in mathematics as compared to in reading. So this is the one way to interpret this statement without any evidence. But if we want to make this meaningful, we have to choose the z-test here and calculate their variations and exact probabilities and exact variations, and can define how much the student is better in mathematics and why not in the reading, or where they lies exactly. So z-score basically help us in comparison, like we can compare uh, without additional information, and we can interpret the results on the basis of z-score by utilizing the current situation and information. So this is the advantage of z-score. By transforming is it takes into account both the mean values and the variability and the set of raw scores. Let us explain here, like the score in pre-test was 18 and post-test was 42. So we have to answer, did Sarah improve here? So to answer this, we have these score pre-test and post-test. And Sarah's score did increase 18 by 18 to 42. But her relative position in the class decreased. How? Let us see here. Here you can see, this is the observation 18. and post-test 42. These are her scores in the test, and the mean of the pre-test is 17, and post-test is the 49. Standard deviation is 3, and post-test 49. So here you can see a big variation in the standard deviation of post-test. So this decreased Sarah's overall evaluation in the post-test. But if we see the scenario here, like the Sarah increases her marks by 18 to 42. But on these basis, we cannot say that Sarah performs well in the class, because here, if we compare the mean and the standard deviation, there is clear difference here. You can see the Sarah is closely related to the mean, and there is great variation in her marks from the standard deviation. But in post-test, the variation in her marks is very low. So here, maximum class scores good, but Sarah is not exist in average. But here Sarah exists in average, so performs better as compared to post-test. So her marks increases, but her position in the class did not increase here. So we can say on the basis of z-score, we can compare, we can conclude, and we see the Sarah performs better in pre-test as compared to post-test. So this is the one advantage or the benefit of the z distribution, as we can only on the basis of this statement, we can only say the Sarah score increases, but basically this score doesn't show her performance in the class as it improves or not. So on the basis of this score, we can easily conclude that if her marks increases, it doesn't mean that she also improves in the class. He just increases or show increment in her marks, but not shows improvement in overall situation. So z-score helps us to compare the series, and this is the one of the benefit of z-score. So normal curve help us to conclude, to improve, to compare the things on the symmetrical curve, on the bell-shaped curve, in which the mean, median, mode are identical, and Gini model distribution, and so many other characteristics. So this is the basic concept, or how we use, why we use, or why we need the normal curve, and how we distribute the area under the normal curve by different points like 1 sigma, 2 sigma, and 3 sigma. So in our further lectures, we will learn about how to apply the practical problem, or how we can solve the Z normal distributions questions, and how we use the normal curve area table. So this is in this video we will learn about the basic concept of normal distribution and what are the benefits or the advantages of normal distributions. Thank you.